Yeah, am I on? Okay. Yeah. Okay. Yeah. Welcome and well, thanks for having me here. I'm going to be talking to you about how we ingest huge amounts of production data into our open source projects. So first of all, who am I? Well, first of all, I'm the son of an electrical engineer, so that's how I sort of got my little hang for this industrial hardware. But I work as a software engineer at a company called Mapped. But for, I think, since 1999, I've been involved in a lot of open source projects. I think currently a committer of 11 or 12 at Apache and even more outside. I'm a member of the Apache Software Foundation, and what really makes me proud is that I'm the initiator and the currently acting vice president of the Apache PLC4X project. If you want to know what I'm up to, well, just follow me on social media. I'm usually quite verbose about what I'm working on. The agenda, what I want to talk to you folks about is how currently we get production data into our software and which problems there are with that. Then I'm going to, well, obviously dig into Apache PLC4X, and especially into one of the aspects I've been putting a lot of my time into for the past few years, our polyglot PLC4X. I'm going to show you some API examples in different languages. And then I've got a part that I'm really sort of looking forward to because I really think that we from the Apache Software Foundation and the Eclipse Foundation, we have a lot to offer for each other. And I just want to point out a few aspects where I think that would be a perfect match. I'm going to try speeding up a bit because I want to have 5 minutes of Q&A at the end. So I'm going to try babbling a bit less and just jumping right into it. So the current problem, well, everything's about IoT and Industry 4.0. But if you have a deeper look at it, well, it's all about processing production data. We've got loads of great open source solutions for processing this data as soon as we've got it. But actually accessing the data on industrial hardware is quite hard. The current solution, well, I put it in double quotes because it's sort of sold as a solution, but I'm going to explain to you why I don't really think it's a perfect solution right now. But if you go to any of the industrial fairs or on Twitter, on LinkedIn, everywhere, it's all about OPC-UA. If you went to the SPS in Nuremberg, that's one of the biggest automation fairs. It sort of looked like, oh, the problem of connecting to industrial hardware is solved. We've got OPC-UA now. OPC-UA has sort of been available for about 3 years, even if the standard has been developed for quite a longer time. In the last 2 years, we've got more products directly supporting MQTT. But both can be considered quite new protocols, especially if you think that some of those industrial automation protocols, they're up to 40 years old. So they're quite new. So, well, if you're confronted with how to sort of get started, well, if you've got a new project, well, you've got no problems at all. You just take new hardware and just use MQTT, OPC-UA, whatever. But as soon as you've got getting to existing projects, things are quite tricky. So in the past, I've seen I've ordered them by the amount of solutions I've seen out there. Well, most of the time there's some SCADA system or some MES system sitting somewhere, and that's got a database. And usually it's sort of like an SQL server or an Oracle database, and people just start picking data out of that directly. Another thing the industry really likes is for us to tear out the old hardware and replace that with new one. What a lot of vendors, the bigger ones, really like if you buy your preferred vendor's integration products. So usually, if you're at one of the big ones, they've got their own cloud solutions, and you can buy their My Cloud solution integration box, and it pumps data up into the cloud. Or, well, you're free to sort of buy any third-party integration products. But there are some obvious problems with this. First of all, the average lifetime of a machine out there is sort of 20 years. So even if we've been able to buy stuff with MQTT and OPC-UA for, let's say, 2 years, and just assuming every device now supports that, well, we've still got 90% of our hardware that's old. So with new projects, the obvious issues, well, there aren't any. With existing projects, well, accessing the database of the MES, well, that's quite hacky. If you replace the new hardware with new hardware, well, that's quite expensive. If you continue to if you use your preferred vendor's products, well, that also is usually quite expensive. And if you buy third-party integration products, well, they're usually not that pricey, but still quite expensive. But one problem that is really annoying the hell out of me right now is this. So if you've tried buying industrial hardware, for the factory you've seen on my cover sheet, I'm trying to buy hardware for that right now. I'm scouting at eBay to buy some used versions because new ones are just not available at all. So what are not obvious problems with this? Well, with new hardware, well, there are license costs for OPC-UA. So just if you buy a new controller that's OPC-UA enabled, well, you have to add usually something near 400 euros per device to turn on the OPC-UA stack. Also, OPC-UA has quite some performance issues, which I'll be mentioning later on. Well, as I mentioned, if you just want to replace hardware, well, right now it's tough luck trying to get them. If you stick with your preferred vendor, well, you're just increasing the vendor lock-in with him. And with third-party integration module products, well, I've had a look at some of them on industrial fairs, and well, let's say some of them I would have severe trust issues with, because pumping my production data into some possibly not secured third-party cloud, that's just not what I really feel comfortable with. So what do I think are the solutions to that? Well, currently all PLCs usually support multiple protocols. Talking to existing PLCs and their native protocols, that doesn't require any modification of the hard or software at all. Some of these protocols are standardized, let's say Modbus, Ethernet IP, Profinet, stuff like that. But some are also proprietary. Let's say the Siemens S7 protocol, I'd call that proprietary, or the Delta V protocol from Amazon. But the devices are able to talk in these. And especially if you start talking in these protocols that are native to the PLCs, then you really get some really insane performance. Yeah, and maybe just as an example, as I mentioned with OPC-UA. With OPC-UA on one of the really big fat Siemens S7 400 devices, we were able to get 200 data points out every 2 seconds. If we wanted more, well, the system just shut down because it was completely overloaded with I/O. And just as a comparison, getting 2,600 data points out of an S7 400, the same device, every 200 milliseconds using the S7 protocol, that wasn't any problem at all. You couldn't even really see a big impact on the I/O. So just because you can reach a system, it doesn't mean it's also the ideal version. Another way, if you want to talk in these sort of existing protocols, well, you can use commercial drivers, but they're usually quite expensive. So when I started a Linux driver for talking to an S7 device, I think it was priced up to 4,000 euros per node, which I call quite excessive. Only a few open source solutions are available out there, because when I was thinking of starting this Apache PLC4X project, of course, I first had a look at if there's any existing thing, because don't want to reinvent the wheel. But there were only very few open source solutions available. Most of them really had a hugely different API. Most of them were abandoned projects. And the thing that annoyed the most out of me was, even if the driver, well, would have sort of been okay, usually the license was very, let's say, business unfriendly. So most of them you can find out there are GPL licensed, and that sort of like disqualifies them for a good usage. So, and that's where my baby comes in. Well, this is the mission statement of the Apache PLC4X project, and I think it sums it up quite nicely. So PLC4X is a set of libraries for communicating with industrial programmable logic controllers using a variety of protocols with a shared API. And the last part is the thing I would like to lay the most emphasis on, with the same API. So if you want to learn more about PLC4X, I strongly suggest you go to our website. But just to sum it up, Apache PLC4X allows you to write software for any type of PLC, for accessing data on any type of PLC. If you change a PLC from one type to another, well, only the configuration needs to be adjusted. The program can stay the same. We've got a large number of supported protocols, and currently we've also got a strong growing number of programming languages that we support. We also support some features that some protocols actually don't really support. There are some protocols, for example, that only support classical read-write, but we'll be emulating subscriptions on that, or auto-discovery. Some protocols just don't support auto-discovery, but, well, if you put enough effort into it, well, you can even get that working. And that's what we're currently working on quite a bit. We've also got a very strong number of growing integration modules, so it's really easy to integrate Apache PLC4X into you can integrate into any other solutions. So what Apache PLC4X supports right now, well, it's classical read and write of data, but also subscription. So you can subscribe for cyclic data. For example, Profinet, you say, I'd like this value every 100 milliseconds, and the system will take care of publishing data. We've also got on-value change. That's very prominent in, for example, the KNX protocol. So whenever a state changes, data, there's an event sent, or what happens quite frequently in PLCs is there's an event, and that triggers something. The community is currently working hard on discovery, so finding which devices do I have, and browse, which tells you which resources do I have on a given device. So, as I mentioned, multilinguality was one of the things that we've been focusing on most for the last 2 years. And that's because supporting multiple languages was planned in from the start. The X in PLC4X stands for the multiple languages. I didn't want to start a PLC4J because that sort of sounded like a waste of effort. Because writing driver code, well, that's actually quite easy. You're sort of like just summing up bits and bytes and then parsing them again. But understanding the protocols, that's the hard part. So as soon as a protocol is understood, it was the plan to create drivers in as many languages as possible. People now say, yeah, well, you could have cross-compiled things or just wrapped it, but that just doesn't feel right. I mean, if you imagine how it would feel using a C wrapper around a Java application, well, that just doesn't really feel good. Also regarding size, that would be have a huge impact. And talking about sizes, well, this is an example of a little application that just reads data using our Modbus driver. The Java application, well, it sums up at 23 megabytes. That's not a problem if you're working on a normal server or a PC. But yeah, I think you can imagine as soon as you start going smaller, that might become a problem. That's where Go comes in. So if you're talking about Raspberry Pi-sized devices, I think Go is a much better fit. It's just sort of a lot smaller, and yeah, well, you've got more room to do fun stuff on the device. But sometimes even that isn't enough. And as part of an EU-funded research project last year, I implemented PLC4C, which was intended for usage on non-POSIX embedded systems, these STM32 type chips, ultra low power. So if you need a device that collects data from a PLC out in the field, well, maybe PLC4C is going to be your friend. But there are challenges with that. I mean, if you've got N protocols and N languages, I think we can all do the math. The number of drivers, that grows quite quickly. And keeping all of these versions aligned is just not possible. Also, testing all of them, having some decent test coverage on all of these drivers. If you find a bug, it's no longer just fixing a bug in one driver. Well, it's fixing that in all supported languages. Or if you've got a problem or an extension in the API, well, you need to update N drivers. And different drivers or languages use different API patterns. So these are the challenges that we had. And just to sort of like show you a picture of the current state, well, let's say Java, C, and Go, that's the part that's already implemented. C# and C++ got quite a lot done already, but Python and Rust is going to come up. But that's sort of like the roadmap. And you can see that's quite a lot of drivers to keep in sync. So our solution was to have a machine-readable but also human-readable protocol specification in which we describe how a protocol looks like. And we create a protocol module for each protocol, and we also create a language template for each language that we support. And we built a Maven plugin that now takes a protocol module and a language template and creates most of the code needed to implement a driver. We've called that specification language MSpec. It was sort of like a draft name, but we sort of stuck with it. And for testing, we built a unit testing framework and an integration testing framework, which are both based completely on XML. And this allows us to specify serializer and parser tests for our generated code, but also on the resulting drivers. The integration tests, they target the full driver. And we can sort of specify test scenarios and have that automatically tested in all supported languages. Here's a little example of how such an MSpec looks like. That's sort of the two top level packets of the Modbus protocol. So you can see up here, this is a TCP version. And down here, we have the serial version. It looks slightly different, but both contain Modbus packets. Unfortunately, due to the short time span of this talk, I won't be able to dig into the details, but I'm more than happy to answer any questions later on or off list. But I just wanted to show you how sort of our protocol specifications look like. The current state, well, PLC4J, PLC4C, and PLC4Go are ready to be used. PLC4Net we're working on. PLC4C++ will probably sort of kill and replace with the PLC4Rust, just because most people working on PLC4C++ left the project, and Rust just feels like a much better road to go. The community is also thinking or getting started on PLC4Pi for Python, but that's sort of still going to take some time. So, as I promised, I'm going to be showing you how PLC4X feels like on different languages. So, for example, this will be a Modbus application using the Modbus protocol, reading one item and outputting that on the console. So, in Java, it looks like this. So, at the beginning, we get a connection. Here we specify we want to connect to this device using the Modbus protocol. So we'll get a Modbus connection. And on that, we ask for a read request builder. That is sort of what we need to create read requests. And what we're doing here is sort of we're asking the driver to read this address. This is an address in the Modbus space, and we're going to name it field in our domain. And this is where the read request is going to be executed. And the good thing is you can sort of execute this multiple times. So you only need to create the request once, and then you can execute it as often as you want. And this is now an example of the asynchronous API. So as soon as the response is complete, we can access the response, or we'll get an exception if something goes wrong. And well, if all went well, we can just iterate over all the fields we had in there and just check the response code. So was everything okay? If it was okay, we'll output the value. Well, if it wasn't okay, we'll just say, hey, well, we got this error response code from the driver. In Go, things look a bit different. We don't have futures in Go. So we're using these channels. Also, we don't have this. In Java, we have all the drivers available that are in the class path. We don't do that in Go to keep to be able to sort of like design how big the application will be. So in this case, we'll be registering the Modbus driver, but now the API is kept pretty much in line with the rest. So we're trying to get a connection. Then if the connection was successful, we're getting access to a read request builder, adding a field to that, getting a read request, executing the read request. And then we're going to wait on a read request response. That could be an error, or it could be something good. So if it was something good, well, we'll just check if it was okay. And if it was okay, we'll just print it out. So that sort of like feels very native for somebody fluent in Go. This one I'm just going to skim because, as mentioned, embedded development with only one thread. Well, you can see the things are pretty much the same, but a lot more verbose because we need to sort of start working with a state machine. But it's working very performant. It's working great on these super small chips. And it's really sort of fun working with things. But admittedly, if you can use the C or the Go or the Java driver, I bet nobody really wants to mess with the PLC4C driver. That's sort of like a measure of last resort if you just can't go that small. So being through with the API examples, now comes the part I'm really looking forward to, because every time I'm doing a talk like this, I always have a look at what projects there are in the communities of the foundation that I'm speaking at. And I'm really, really looking forward to sort of joining forces with you guys, because especially yesterday, I've seen some really great stuff that I really think we can bring benefit to each other. For example, I just had a look at a lot of the Eclipse projects support only a few direct types of connections. So I had a look for Diag. I could see PowerLink, Modbus, MQTT, OPC-UA, and OPC-DA. So that is by far the most protocols I've seen. PowerLink we're probably going to have in PLC4X soon. Kapur only seems to support MQTT. Cura, I've seen Modbus, OPC-UA, S7, and MQTT. But what I've seen when I had a look is that S7 usually wraps Mocha 7, and that has the same license as Snap 7, and that's a GPL licensed library. So I think I wouldn't even count that. Milo, oh well, obviously that supports OPC-UA. Mita, it sounded very interesting, but as far as I could see, only onboard Arduino sensors was supported. But just thinking of supporting Profinet drivers, that seems like a really cool thing to do. Well, Mosquito, obviously MQTT, and Paho also MQTT. But I've read that they they didn't even plan it from the start to just support MQTT. So, well, if more support was going to be added, well, maybe we should join forces. From my side, things I've actually been actively using is Yocto. So that's definitely my favorite build system for Edge OSs. And I was really happy when I heard about the launch of the Eclipse Oniro. I hope I pronounced it right. Which I think might be the perfect platform to run PLC4X applications on the edge. So what we have to offer, well, these are currently the drivers PLC4X supports. So if you want to have these drivers in your projects, well, just reach out to us and we'll be happy to help. The thing is, at first I started working on this on my own, sort of like preparing something and then offering it to the Eclipse community and saying, hey, I've got something here for you. But that did have some challenges. So, for example, I've tried starting with a PLC4X Cura integration because I really think that Cura would be the perfect match for PLC4X. But let's say I was pretty soon stuck with a, let's call it, creative way Maven is being used in the project. And this is also probably going to prevent us from adding it to the PLC4X project. It's more sort of like a technical project problem of getting this integrated into the build, getting this working in our release process, all of this license header notice and license stuff. It would just sort of bloat the release of PLC4X. So that's probably not going to happen. Integrating the implementation itself, I think that would be a matter of a day or two for me. But getting started with the project, the build, the best practices and stuff like that, that's just a matter of weeks. And I think working together just makes a lot more sense. So I'm just going to skip over these because I think it's sort of like just the same. So if you want to join in, help out, just say hello on the mailing lists, say hello on Twitter. Yeah, we're happy for anyone that sort of wants to help out. So thanks, and I really hope to really see you guys because you're seeing me, I'm not seeing you, and that's one thing I'm really missing out on. So let's see, I think I've got 3 minutes for 3 questions. So question number 1, in the protocols PLC4X supports, which one are the most mature and which ones require more work? Well, definitely the Siemens S7. The Modbus and the Beckhoff ADS, I would consider the most mature ones, but that's mainly just due to the fact that they're probably most used here in Europe and Modbus in Asia. The other drivers, let's say the OPC-UA driver, we now have our own one. It's very new, but I think all of them sort of are doing their job. But we just don't have much feedback on how well they're doing it. The second question was, your presentation mentioned MQTT. Are you familiar with Eclipse Sparkplug, which runs on top of it? If yes, what do you think about it? Yeah, well, I think Sparkplug is sort of, as an addition to MQTT, is sort of the perfect match to being sort of outperforming OPC-UA by far. Right now, I think we probably wouldn't integrate PLC4X into Sparkplug into PLC4X directly. But what we're thinking of is sort of like creating a gateway to be able to talk to legacy hardware using Sparkplug. And some of our friends here in Germany, especially Dominic, I think he's very involved in the project. I'm really hoping on being able to work with him on that. Question 3, how do you ensure quality of PLC4X with polyglot integration testing? Yeah, well, as I mentioned, we decided to sort of, we're creating more and more test scenarios. Sometimes we're even building tooling to sort of out of recordings, Wireshark recordings, to create test suites from that. So what we're doing is we're defining more and more of these XML-based test suites, and we have runners in each language to run the drivers in that particular language. Admittedly, in C, it's a problem because doing XML processing in C, well, that's just a huge pain. So there was a fourth question, but I was just told that we're out of time. So sorry for the race, but I hope it was interesting for you guys, and I'm really looking forward to meeting with you.